Hello everyone, this is Suresh here. So welcome back for another Google Cloud lab session. So in this lab, we will into the Vertex quick start. Without any delay, let me start the lab. And in this lab, we are going to only perform the task provided for us, and we are not going to discuss anything theoretical or technical stuff. Okay? So the intention here is how to execute the task provided for us in the Google Cloud environment. So without any delay, let me start the setup. So if you need anything, you can pause the video and go through the overview about the BigQuery and what it's AI. And in this objective, we are going to train a TensorFlow model locally hosted in Vertex notebook, and visualize the TensorFlow board. So I think I have done the setup here. Let's double check that. Yeah, let's activate the Cloud Shell. We want it to be activated. And once it activated, we'll authorize the couple of two steps, couple of optional steps. Step two and step wait for it. Open it in a new window. So that you can see the screen. Gcloud auth list authorized. And you can see the student is active. Gcloud config project list is active. So let's enable the task one. Enable the Google Cloud services. So you can pause the video and check what are all the services we are getting in. Okay. So let's check the progress. Let's wait for a few moments. In the meantime, we'll move on to the next step. So go back to the dashboard. Okay, navigation menu, Vertex AI, dashboard, all recommended API. So you can see this in the notification window. So let me just okay. Go back to the workbench here. Workbench, step 4, and step 3 and 4. The instances view, create new, live workbench, in the central one view, and rest all optional steps. And if you want to see, just I will give a continue, and you can check the environment to continue. And you can see the machine types and Russia and other default. And you can see the disk sizes, networking information, VM security information, system health, and TCOM create. So this creation is going to take about 2 minutes. So let's wait for until we can see this open lab. In the meantime, let's check the progress on the task one. Yeah, task one is complete. So let's wait for the step number 8 to be made. It took about 4 minutes to enable this. So let's open Jupyter. It took about 4 minutes for the instance to get created. So I opened up the step 8 is done. So let's wait for the step 9. So we're done now. Check the progress. Now let's clone the repository. So copied. You can clone this repository to your local machine to verify the files or go through the templates that you needed. For this, you don't need to verify the files and all. You don't need to put it Google Cloud or system. So you can see this. It's publicly available for everyone. So you can download it. You can clone it factory to check the files. So lab is done. Let's check the progress. Looking good. Now you can see this command is saying us to navigate to this location, install the requirements, and write down their. So before getting into that step, I just wanted to manually show you that what this file contains. The self-paced set of labs, text statement, text quick start, and the requirements. You can see these are all the requirements that is getting going to get installed. So let me copy this to the terminal. This is going to take some time. Once we're going to ask us to waiting for the step to confirm to arrive. So this is going to take another couple of minutes. So you can change. So it took about for the screen, it took about 2 minutes. So let's proceed with this. Yeah, now looking good. So now let's run the lab. Okay, same navigation, quick start, lab exercise. Continue in the lab as well and maybe each. Okay, minimize the sidebars. Give more space to the content. Okay, so here I'm not going to explain anything here. So at least you can pause the video and go through the content if needed, or you can clone the repository and you can find the same file in the same location. That's fine. So let's see what's in. This is predictive CLD. Okay, this one I have already done in different version. Let's see. Okay, step one, part, dependencies part, fine, looking good. Project ID and region environment. Okay, this is also looking good. This is bucket, initialization of a bucket. Okay, in this region, it's going to create a bucket. Basically, what it does is this in this region, this is the region is US Central one and the bucket ID. Okay, let's we get to we duplicate this console and navigate to the cloud storage. And see the bucket with the name. You see that project ID hyphen bucket. This is what it is getting created. Okay, so let's move on. Importing the libraries. Okay. And also importing the Vertex SDK for Python into Python environment and initializing it. For this, here platform.initializing project ID, location region, and syntax is here. So I'm waiting for this kernel to get completed. It is busy right now, so we will wait until it get ID. In the meantime, now good. Okay, initialization is done. And you can see the data set and this data set and its relation. And you can go to that line tree type. So basically, this is UCI machine learning repository. So this is the data set they have been using. You can note the URL, get the download dataset you need. For other things, you can go to this URL and extend the customer load. This is the training we are going to do. So there is a lot of information over here. This is the training lab session. And BigQuery constants. So we are not changing anything here. So we are just shut enter and you can names, BigQuery name, table name, clean data, EML data, BigQuery projects. So next, this one will take some time. It will take about 2 to 3 minutes because it needs to download with all of the information in it. Sometimes you can see it in the website as well. You can see this data is getting converted, downloaded, and getting converted. So it will take about 2 to 3 minutes. We'll leave here, and I recommend to go through the details of this and understand the concepts first, and we have then go through this video again. So because within 45 minutes we'll not be able to explain each and every aspect of technical theoretical aspect of this lab. Okay? The only purpose of this lab is to just to create the steps that is provided for us in the Google Cloud. Okay. Okay. So the step is completed. It took about 2 to 3 minutes, and you can see the steps. So downloaded, converting, uploading the to CSV, copy to local CSV, cleaning of the data, initialize it the BigQuery, created the data set. You can see this data set if you want. Yeah. So do another duplicate here. If you want to see the data set, navigate to the BigQuery. And you can see the project and you can see online retail. Yeah, you can see here, this is the project ID and the data set is online retail. You can see the same here, online retail. You see three raw data, machine learning data, and the clean data. All three is available. You can view here, but the lab asks us to view itself. Okay, I will leave the provision here for a second. You can pause the video and go through what this will be does. Okay, so here basically what we are doing is DNN, deep neural network. This way we are going to predict the monitor value. Okay. Now, let's going back to the EDA in BigQuery. You can see online retail CLV. In BigQuery, you can see online retail CLV open ML underscore ML. This is the data it is going to print. Basically, this is the query we are going to execute. So select job is done. You can see the description count is about 3,330 and all other metrics. And you can see the history in bits. The inference, you can see in the bottom, they have already provided the inference for us so that we can understand. Same way, number of purchases, you can see the frequency of number of purchases and you can see the description and the bins as well. I will leave it here. See, all these things, all these metrics and all, it's really you have to dig deep and analyze it for offshore time, I mean, your personal time. Again, using the chart, this is the inference is there. Now let's try with target monitoring. Okay, subscribe and see. And you can see the monetary of 2,355. And there is a minimum And this is one of the tick name of this table. You can inference from that simple baseline. So here the values not here to explain what this code is. For each line, there is an explanation. This is this URL. URL, I mean, SQL queries from day intervals and also predicted CLV SQL query. This is for the clean data and this is so there is a lot of information here. And we recommend you to analyze this or download this code and analyze each and every step for better understanding the whole project. MAE, MSA, and RMS. Okay, please and the plot. Yes, I said we have the information and the plot you can see. Actual versus predicted customer 3 month monitoring. Right. Now, train a TensorFlow model locally. Okay. This is the second objective of our lab. So let's do the same. We do it by data split. Okay, now data split has been split into three: test, train, and validate. You can see the ratios as well. Now here, this is where we are defining the training parameters. Okay. Again, each line has have its own information about each line. What are the epochs? What are the checkpoints? Batch size, examples, and those things. So there is actually 5 features and 1 target. Okay. Now, let's transform the data from to. So here itself, they have given why we are needing this data set. Again, these are all theoretical guys. So I recommend you to understand what is the data frame, what is the data set, data frame in pandas and TensorFlow. What is the difference between TensorFlow and all you have to do research. Because this session is not to understand and discuss about this. Now comes the main part. Okay. We are building the RMSC and the building a model with the parameters. And I can see some parameters here. So they give a number of the features. We are doing the normalization, also the tens. You can see the ReLU and the two tens. The neuron output for recursion. Keras model optimizes Aaron has been used on the learning grade. I think define it. Good. Now this is the plotly model. Now you can see the model, whichever we have defined, is exactly the graphical representation. And you can compare this. Now you can see input layer. The input layer where we have 5 input layer, 5 features correct. And normalization, you can see the normalization here. Concatenation and then dense. You can see activation reload, dropout, again another dense. So, okay, let's move on. We are taking more time for this. Okay. Now tensor board has been defined. Fallback and gives waiting 2 seconds and checkpoints. So now we have model fit is done. So this is going to be a 10 epochs. The model is getting trained. In the meantime, you can see the MAE, MSC, and root square, root mean square depth. You can get this. So 1, 2, 3, 4, 5, 6. I think that's it. So there is a stop. Maybe you can get into the code. We call it as early stop. You can get into the code and check what that early stop is. Okay. Now moving on. Loss. You can say 6 iteration loss and value loss. Train. Okay. Similarly for the data frame and model prediction calibration parts. Again, this is a huge file. I recommend you to download the file and get into these details. You can see some of the predicted training using the train data, actual versus predicted, dev data, as well as the test data sets. What I did. Yes, this concludes the session. Thanks for joining.